the picture for how we're going to work. This is a kind of question that, anyway, the computer has a better chance of answering. I mean, this is a function with an infinite domain, so you can't, if all you could do is compute these functions on each representation of k, that's not good enough to answer the question of whether the function is 0. But what we're going to do is, well, we're going to write formulas for these functions that, well, it's easy to tell from the formulas when they're 0. That's the plan. Anyway, so tomorrow I'll set up this notion of Hermitian forms more carefully and see what it is we have to calculate and start talking about how you calculate it. That's the plan. Okay.
Questions? All right.
What you said about not being able to determine when the signature is 0 plus.
So it could be that what Atlas was able to do was compute these functions in the sense if you give Atlas a particular, well, a representation of G and a particular representation of K, then Atlas maybe could compute the values of these two functions at that representation of K. And by doing such calculations, you might be able to prove that a representation is not unitary, but you could never use such calculations to prove that the representation is unitary. Because, you know, you could check the first 6 billion representations of K and find that all those signatures were definite, but if that's all you could do, it was, you know, if this was just a box for computing this on a particular representation of K, that wouldn't tell you whether something is unitary.
And it still amazes me that we've somehow gotten around this problem.
Yes.
It's you know, how do you make this a finite calculation?
Yeah, well, I mean, I'll be explaining that we do all this linear algebra. All you have to do is invert this upper triangular matrix. Well, it's an infinite upper triangular matrix. But it's okay.